Now that we've seen an overview of AGI software, we're going to talk some more specifics about how that software can be applied to C4ISR systems. And you can really break that down into three ways that customers use AGI software in C4ISR systems. The first way is in system analysis, simulating a future system or a system that they want to procure to understand how well that system will work for a given mission or in a given area. Second, operational planning of intelligence, surveillance, and reconnaissance, or ISR assets. Deconflicting flights, making sure assets aren't going to collide or assets aren't going to be covering the same area. Fusing ESRI or ESRI geospatial data, or many different types of geospatial data, to form a common understanding of the environment, and actually integrating our software, our desktop software, integrating it into fielded applications, integrating it into your own software development tools for thin client applications, web applications, or just deployed systems that are used by operators with a specific and unique workflow. Finally, the last area is in real-time operations, taking in telemetry from radars, sensors, communication data links, and fusing them to create tactical displays of live asset management. Where is that aircraft flying? Where is his sensor looking? Where are all of my assets, and where have they seen? Where have they been over time? So really, our software combines system design, pre-mission planning, real-time live online analysis and visualization, as well as post-mission analysis in one set of tools. So let's talk about these a little bit more specific. The most historical and commonly used aspect of our software is in system acquisition and system analysis and engineering. There's a lot of challenges in these, in military and ISR systems. It's very difficult to predict these future requirements, and it's even more difficult to understand how well an asset will actually perform in a given mission. And it's difficult and very expensive to field test or flight trial these new systems. So AGI software adds the benefit of assessing threats and engagement strategies and allowing you to quantify the performance of that new system, so you can simulate systems of systems to reduce the risk and increase the speed that you can actually procure or develop a new system. In summary, we're taking a wide variety of mission variables, performance characteristics, sensor characteristics, communication characteristics, and combining them for comprehensive and scientific decision making. As an example, the U.S. Air Force was recently trying to decide whether they should procure very large radar aircraft or smaller aircraft with smaller radar capabilities but faster. Which asset would provide the fastest kill chain and detection for a given area of the world? Now, the Air Force A9 ISR lab was given a year to perform this study of which aircraft to purchase. Now, they purchased STK, brought in the STK models of sensors, platforms, and mission scenarios, and combined that with some logical loops built in MATLAB, and they were actually able to perform the exact same analysis that they've allocated for a year. They performed that analysis in 1 month. In fact, they actually performed more analysis than they had originally intended to, 12 times faster than initially thought possible. That type of very broad mission simulation performed very quickly right out of the box with this off-the-shelf software, integrating with existing data and existing tools they had in their simulation lab. Now let's take it a step further. Now that you own or are operating an ISR asset, you have to plan the missions to use that asset most effectively. And there's a lot of challenges in that as well. Every different asset has different performance. Some aircraft fly faster than others. Some aircraft fly higher than others. Some ships have more powerful radar. Some satellites only come over once every week. Some come over every day. Different sensors have different capabilities. Different communication assets offer different range and endurance. Not to mention, assets operate in different mission environments. Operating over the ocean is very different from operating over the mountains in Afghanistan. So understanding how an asset is going to perform is very important. And these objectives are changing rapidly, so being able to very quickly quantify these performance becomes very important. What's great about AGI software is it allows you to rapidly plan for a multitude of different assets and model any payload on any of those platforms: communications, radars, electro-optic sensors, IR sensors, and bring all of those models into a realistic mission environment so that you can rapidly quantify how well a mission is going to be performed and change the mission specifications, which asset, which sensor, etc., so that you can optimize your use of limited assets. So let me give you an example. We take all of these different areas, GIS data, route deconfliction, sensor performance, communication, radar, and fuse all of these into a mission planning application. This example is the Airborne MASINT Mission Planner. It's a mission planning solution that's currently used on board Department of Defense aircraft for planning measurement and signals intelligence missions. Now, this is a really complex mission. They get thousands of requests to collect data over thousands of different targets. In the past, the planning for this type of mission spanned over 2 days. But what this customer did, ITT, they purchased STK software and they integrated it into an onboard mission computer, a data set, and a GPS tracker. So that instead of doing planning in an offline environment, they allowed AGI's aircraft models and sensor models and terrain interaction to rapidly plan these missions while the aircraft is airborne. So while an aircraft is flying into theater, they optimize the mission while they're flying. They took a 2-day cycle and reduced it down to 2 hours. And when something changes, they can replan it in just minutes. Not only is this onboard aircraft and operationally used, but they delivered the first prototype in less than 90 days. So AGI software allows you to build these very, very complete and effective mission planning tools and deliver them and integrate them into your own workflow so they can be used operationally very quickly. And finally, one of the most common areas of wide-scale adaptation of our software is using the visualization engine in our software to monitor and analyze real-time situational awareness. In the modern battlefield, it's very difficult to understand all of the different data coming from all of your different sensors, all of your GIS and intelligence and telemetry, and it's very difficult to balance tactical data, like an individual UAV video feed, versus strategic information of population density, geospatial information of troop strength, and different things across the entire battlefield. How do you fuse those into a picture that can allow you to understand both simultaneously? Obviously, there's systems already in place in battle management systems, command and control systems, and air traffic control. So it's important to interoperate with those legacy systems. Thankfully, AGI software allows this optimized real-world, real-time virtual environment where you can bring in real data and simulated data overlapping. You can augment reality. AGI's architecture is very flexible and scalable, so that you can run this on a laptop, or this could be running from a website, or even deployed on lightweight portable devices. And what's unique is being able to fuse those strategic geospatial data and track and telemetry data fused with sensor overlays to create an augmented picture of what the battlefield really looks like, and essentially shorten that sensor to shooter loop of what did one of my sensors, what did one of my troops see, and how can I make a decision to act on that, allowing me to make much improved tactical decisions. So again, uniquely, we're bringing all of these different aspects of planning, four-dimensional geospatial data, telemetry data of blue force and red force tracking, sensors of different types being fused into one picture, and including the sensor payload so you can see where are my assets looking, allowing you to analyze what areas have been covered or are being covered or will be covered, and actually perform real and live analysis. When do objects enter and exit a volume? Are any of my aircraft in a surface-to-air missile threat volume? Has an enemy ship come too close to one of my borders? Am I about to lose line of sight with one of my unmanned aircraft? These types of analyses can be run in real time to allow you to make better decisions about what's going on in your ISR operations. So for example, we'll see these uses here of real UAVs being operated in the field and their telemetry and sensor data being streamed back into AGI software. This is from live trials in California, and we'll actually see the telemetry being streamed back into AGI's virtual world. So this is real terrain data, real telemetry being visualized with augmented reality of historical track data, altitude data. What has my aircraft seen? Seeing a virtual depiction of where the sensor is looking so that a commander can see in an instant what areas have been covered or are being covered at the time that they're looking at this, or looking at historical or planned sensor coverage maps. Taking this a step further, AGI software allows customers to actually take the real-time video that's being collected by sensors and overlay that in the virtual environment. So here we're actually seeing the live video stream from a UAV that's up here. We're seeing the virtual footprint and the real video being draped over that 3D environment, so we can quickly understand what's been covered and what hasn't been covered, and we can fuse that strategic data of maps and geospatial information with the live video of what's currently being detected, giving us much more enhanced situational awareness of how this is being used. And not just for an individual asset, but for thousands of assets, fusing them together to create a common operating picture where you can understand airspace volumes, political boundaries, the positions of live tracks, and where they're all operating. And let me give you an example of a real application of this. In the United States, we have a command and control system called the Global Command and Control System, joint. There was formerly a maritime and an air version. Now these are combined. And they had a two-dimensional viewing application. Unfortunately, as the battlefield became so complex, they needed to understand altitude, they needed to understand which were aircraft, which were troops on the ground, and they also needed to understand sensor performance. Where were they currently looking? Which sensors were active and which were not? So Northrop Grumman a U.S. company, purchased AGI software and used AGI software to create the Tactical 3D Common Operating Picture, or T3D COP. So they took commercial AGI software and integrated it into an existing command and control system. This allowed commanders to have a much more synchronized view of the two-dimensional and three-dimensional environments and a much greater improved situational awareness, so that they could understand things, not just where are my assets, where are my blue forces, where are the enemy forces, but they could start to understand where are surface-to-air missile sites and are any of my assets close to them. If I have airborne radars, what area is being covered by those airborne radars? And that allows them to understand very critical pieces of information, like, are there really no red forces here, or am I just not looking there? Do I have no sensors looking in that direction? All the way from a strategic perspective, all the way down to individual assets. You can actually see a single Blue Force unmanned aerial vehicle fusing the video and everything together into one common operating picture, so you can instantly access strategic information and tactical information to make the correct level of decision depending on who's viewing the software at any given time. Not to mention that our software is completely interoperable with a number of other commercial softwares, so much that the U.S. has identified AGI software as part of the Commercial Joint Mapping Toolkit. You can go to this website to learn more about it. But understand that AGI can be used to natively fuse all of this different data together with common data formats and be used for a number of different ISR planning applications. So just as a recap, whether it's in systems analysis, planning or operations, or real-time, AGI software can support a number of these different applications. And now I'm going to actually show you some of these through a demonstration of the software. This is a desktop version of our software, but as I mentioned, all of this software can be integrated into existing or into new mission planning and real-time monitoring applications. So of course, the first thing to understand is that our software offers a unique way to fuse terrain and imagery data in a high-performance, three-dimensional environment. Here we're looking at terrain data around the Bagram area of Afghanistan. What we're going to be looking at in this scenario is understanding the performance of an ISR asset, a UAV, performing surveillance over this mountainous region. We'll have a ground control station located in an air base and a search area that we are responsible for covering. We know we're searching for some targets in this area, and we want to understand how well we can actually track those targets. So here's our ground control station, and here's our search area, just to give you a perspective of where we're operating. Now the first thing that I want to understand is, based on a ground station here and a search area here, am I able to communicate with an asset as it's operating in this region? I've defined that I want to operate at 9,000 feet to maximize my surveillance resolution. So what I'm going to do is I'm going to look at the 9,000 foot region, and we can see here's my 9,000 foot region, and I'm going to analyze line of sight from my ground station to that whole region. What I'm seeing is that the areas in red, I do not have line of sight. The area that's green, I do. So just to understand, let's start a little bit higher, and let's start at 13,000 feet. let's see what's visible at 13,000 feet. And I can see that pretty much everywhere in this 13,000 foot region is visible. So if my aircraft flies anywhere at 13,000 feet, I'll have communications with my ground control station. If I move down to 12,000 feet, I see that there's some areas that are blocked. And I can instantly see from my 3D environment that this mountain peak right here is what's causing that blockage. So I'm going to isolate this area here, and I'm going to create a no-fly zone. Tell my aircraft to stay out of this area, because if I fly within this red area, I will lose communications with my aircraft. And I can continue going down to 11,000 feet, building up a new area, to the point where I can actually build a unique no-fly zone that is specific to the location of my ground control station and the local terrain. Very quickly, I'm understanding how does the local environment affect my ability to perform surveillance and reconnaissance. Now, because I'm operating close to mountains and I may be using GPS-guided munitions, I want to understand what my navigation accuracy, how well will my navigation solution work in this area. I can see that I'll have anywhere between 30 and 35 feet of accuracy at this given time. Now you may wonder how I calculated that, but you have to understand that AGI can actually simulate the entire GPS constellation, which is constantly in motion. So every moment of every day the GPS satellites are moving, and depending on the terrain and the different asset that you're using, where you're flying and where you're operating, your accuracy will change. But for my purposes, I determined that it's okay, I can actually operate, so I'm going to give my mission a go. So going back to the airbase, I'm going to start operating my aircraft. Now, I'm going to be operating here in both a mission planning perspective, but think about this in a live, real-time mission operation. You can see that in addition to seeing the trajectory of my aircraft, I can also see the terrain interaction of my sensor and get visual cues as to where that aircraft is operating, such as altitude from the terrain, the sensor footprint intersection. And you'll see that as I get closer into the operational area, that sensor intersection becomes very complicated. And as I'm operating over a sustained period of time, I can start to see how that terrain and how my flight path is affecting the areas that have been covered. What I'm showing right now is a very unique capability of AGI software. Understanding where a sensor has actually covered the ground given the terrain interaction. In my work with UAV operators, they've mentioned that situational awareness is the single largest problem and challenge to operating unmanned aerial vehicles. Imagine trying to identify your wallet in your bedroom, but you can only look through a thin soda straw to cover the entire room. That's the challenge that UAV operators are, except they're trying to find something the size of a needle in an area the size of a football field. So, still looking through a soda straw. So, giving this type of coverage analysis to allow them to understand what areas have been covered by the sensor and what areas haven't gives operators and commanders a very powerful understanding and ability to use their assets more effectively so that they don't cover areas multiple times, but they don't miss areas also. Now, once you've gone to the end of a mission, or you've finished planning a mission, there's a number of post-mission analyses or mission coverage or different types of reports that are available within AGI software. So I'm going to remove my no-fly zones and just look at, having performed this flight, how well did I cover this area. let's look at my total coverage. What you're seeing is the amount of time that my sensor covered the ground in my search region. Red areas got covered just for a second, blue areas were covered up to 45 seconds. And you can see there are areas that were completely missed, and there are areas that were covered a lot. Now, my intelligence had told me that the enemy was most likely down in these valleys, and I can see that I had quite a bit of coverage down in these valleys. However, because I was forced to fly so high, we can now look at what we're calling our range constraint. How far was my sensor from each point on the ground? You can see that the blue areas, my sensor was very close. Those are the areas up on the mountaintops. The orange and red areas were down in the valleys because they were much farther from my sensor. This can be directly equated to what resolution could I achieve with my sensor. You could equate this to the green areas are the areas necessary to actually detect a person with my camera's resolution. So now I can see that all these areas down in this valley were actually not taken at a high enough resolution to actually detect the targets that I was looking for. So this mission plan would not have worked. So let me see some different operational concepts. Let me try using a second ground control station closer to the area of operations. I can see a terrain mask of what's visible at a given range or at a given altitude. So this highest altitude here, that shows the altitude of 9,000 feet where I wanted to operate. You can see that most of the area in the valleys is actually visible from that 9,000 foot area. And if I perform the same analysis that I did previously, I can see that at 9,000 feet, this whole green region would be detectable. So if my ground control station were located here, I could operate at 9,000 feet and detect my targets at the resolution that I needed. However, if you're looking for enemy targets in this region, you probably don't want to put your ground station right next to the enemy. So let's evaluate a third option. Let's look at building a communications relay. So taking a step into the RF or radio frequency domain, we can see that using a radio frequency and AGI's communications simulation capabilities, my original ground control station, even though it does not have line of sight to the 9,000 foot operational area, some power does actually get received. What you're looking at is the received power at each point in this operational area from my ground control station. And you can see that the areas with direct line of sight have high power, and the areas that are blocked by mountains have lower power, and the areas blocked by two mountains, 1, 2, have even less power. But let's try calculating a new computation where we add a second UAV to operate overhead as a communications relay. So now instead of broadcasting directly from the ground station to this area, we're going to broadcast from the ground station to this UAV down to this area. And what you're going to see now is we actually had to change our scale because we have such better performance. With this second link here, and we can see that link visualized by this yellow line connecting the ground station to the second UAV to our original UAV, we get much improved performance. So we've just used AGI software to evaluate two different ways to improve our surveillance coverage over this area, using a different ground control station location or using a communications link to fly at a more optimal search pattern or search altitude given to increase our chances of actually completing the mission at hand. So in summary, whether you're purchasing a new system, designing a new system, or deciding on what's going to be the best system to meet a mission needs, you can use the software to simulate system performance over a large area. You can use the software integrated into your real operational planning to plan a mission and make the best use of the assets that you have. And you can monitor your missions, fuse lots of different data together to get the best real-time decision-making capabilities possible out of your assets that you have.